Again, we're supposed to rationalize the denominator. In other words, I have to eliminate the square root from the denominator. We said anytime we want to eliminate square root from the denominator, we're supposed to multiply numerator and denominator of the fraction by the conjugate of the denominator. Okay, so I'm going to multiply numerator and denominator by the conjugate of a minus square root of 11. The conjugate of it is a plus square root 11. Whatever I did in the denominator, I have to do also in the numerator. So I have a plus square root of 11. Now, anytime we multiply fractions, we have to multiply numerator by numerator and denominator by denominator. 1 times a plus square root of 11 is just a plus square root of 11 over, now take a look, I'm going to apply this formula, okay, the difference of two perfect squares, which says that binomial multiplied by its conjugate gives me first term squared minus the second term squared. This is my first term and this is my second term. So I'm going to write a square minus square root of 11 square. This exponent is equal to my index. There is invisible 2. That's why this 2 will eliminate my radical sign. That's why I'm going to have a plus square root of 11 divided by a square minus 11. Now, please notice that at the beginning we had square root in the denominator. Now, we do not have square root in the denominator. And this is the solution to my problem. Let's take a look at the second example. Again, we have square root in the denominator. Okay, and don't forget this is binomial. Anytime we want to eliminate this square root, we have to multiply numerator and denominator of this fraction by the conjugate of the denominator. Conjugate for this expression is going to be square root of x plus 1. Whatever I did in the denominator, I have to do also in the numerator. Plus 1. Next, I have to perform the multiplication. Anytime we multiply fractions, we have to multiply numerator by numerator and denominator by the denominator. That's why I'm going to have in the numerator x minus 4 times square root of x plus 1. And in the denominators, I'm going to apply the rule for difference of perfect squares, which says that anytime I have binomial multiplied by the conjugate of itself, this is equal first term squared minus second term squared. The difference of squares of these two terms. So I'm going to have square root of x square minus 1 square. This is going to be equal x minus 4 times square root of x plus 1 over this exponent is going to eliminate this radical sign. That's why I'm going to have x minus 1. And this is the solution to my problem.